Hello one and all, and welcome to the Math Magic Show. In this one we're going to take a look at examples of factoring with negative exponents. So this kind of factoring sometimes can be quite tricky, so I'm going to try to develop a kind of general procedure that works pretty reliably and is pretty mechanical too. So I have as an example, I'm going to give you some examples. I have here x squared, say, plus x to the negative 1/3. So there's a negative exponent present. How do you know what to pull out and whether or not there actually is a common factor? It doesn't seem like it at first, but there is. So what you may want to do first is just draw a little number line for yourself. Not that this step is not really necessary 100%, but I just want to be able to visualize things a little better. And you see if the 2 goes over here and the negative 1/3 goes over here, so because the negative 1/3 is smaller, that tells you that to do this, what you can do is just divide each term by x to the negative 1/3 and place x to the negative 1/3 outside of parentheses. So what I mean is this, take a look. It's x to the negative 1/3 outside the parentheses, and then just divide each term by x to the negative 1/3. So it's x squared and then x to the negative 1/3 plus x to the negative 1/3 over x to the negative 1/3. And why would I do that? Because since I'm factoring x to the negative 1/3 outside the parentheses, notice that now this right here will become equal to 1. Any quantity divided by itself is 1. So that's going to give me x to the negative 1/3, and then in this position this is 1, plus 1 that is. And then what happens to the x squared divided by x to the negative 1/3? Well, as long as you follow the basic rules of exponents for division and so on, it will tell you exactly what term is to be placed before the plus symbol inside the parentheses without any guessing. So what I mean is, take a look. You do x squared over x to the negative 1/3, which is really, by the basic laws of exponents, x squared minus that negative 1/3. The bases are the same, so in other words, right, this matches this, so then you just subtract the exponents. The exponent in the bottom is already negative 1/3, so that's telling you that what you have to do is minus negative 1/3. So in other words, it's this part right here. That's negative 1/3, so here you take away that. And then you just simplify this, so it becomes x squared plus, and then 1/3. And of course, normally we would not write this by just adding up the values. So I would have, let me convert 2 into thirds, that is 6/3. 6 divided by 3 is 2. So plus 1/3. This then will give us x to the 7/3. So that goes over here, x to the 7/3. And notice, in other words, there's a very specific procedure in place. Pick out the smallest value that you see. That's pretty much the term you're going to factor out. Divide everything by that term. Applies to the basic laws of exponents, and you're going to get the factorization correct pretty much every time without any feeling your way through it or guessing or not being sure whether it's right or not. This is one example, perhaps at a somewhat elementary level, as far as these things go. Let's do a more complex example now, okay? So, let me move down a little bit. Okay, so in our little factoring world, I'm going to now go with this example. So that says x plus 1 to the negative second. So the x plus 1 this time is within a parentheses and it's raised to the negative 1 second. And here, for example, I'm going to have x plus 1 to the negative 1/3. So how do you factor this? It doesn't seem like there's anything that you can do, but of course there is. So again, what you want to observe is, for example, this. Put the exponents on the number line. Not that this step is 100% necessary, but just as a way of organizing it. You see that the negative 2 is here, and the negative 1/3 would be about here, right? Imagine this is 0. Then the negative 2 is clearly more negative. It's, in other words, to the left of 0 more than negative 1/3. So you want to factor that out, potentially, as an example. So what I would do is this. Just divide everything through by it, and then put a version of it also outside your parentheses. So x plus 1 to the negative second, okay? And then you're going to have here x plus 1 to the negative second over x plus 1 to the negative second. That's a 1 in that position, to be clear. And then over here, let's be careful. I'm going to have plus, and then x plus 1 to the negative 1/3 divided by x plus 1 to the negative second. And I can do that for the following reason. Remember, if I bring this quantity here back through the parentheses, it would cancel with each new denominator and would restore the original expression. That's why I can do that, okay? So I'm not really changing anything, I'm just making the appearance look a bit different. But now, of course, this part, since these things are the same, that becomes just 1. So the next step, I'm going to have the following. X plus 1, and then to the negative second, then this will be a 1 in this position. And then what remains in the second position will be exactly what we did in the previous example. So I'm going to call this some side work, just because I don't want to cram too much into a single line. So this is going to look like this. I'm going to have x plus 1 to the negative 1/3 divided by x plus 1 to the negative second, which is equivalent to x plus 1 to the negative 1/3. By the laws of exponents, it would be minus a negative 2, the same as before. So in other words, this is a negative 2, so this is also a negative 2 in that position. And then you just simplify this. So again, x plus 1, negative 1/3 plus 2. Then you just rewrite the 2 in its appropriate form. So it becomes x plus 1, negative 1/3 plus, that would be again 6 over 3, correct? 6 divided by 3 would give you the 2 back, and then you can finish this up, so it becomes x plus 1 to the positive 5/3. So here you're going to put now plus x plus 1 to the positive 5/3. See that? And it worked like magic. It is a bit of an extensive procedure, especially when you're first learning it. So I've shown you a method that's very reliable and mechanical. As long as you follow it, you very likely will get the correct factored form of the expression. But once you've done it a few times, perhaps you make some observations about how to shorten the process or how to skip some of the steps. I just wanted to show you every detail to be clear on everything. Okay, well, that is it for me. Thank you so much for watching. Please leave a like and subscribe. I'll see you in another mathematical adventure.